In 1950, the physicist Enrico Fermi sat down to lunch with some colleagues and asked a question so simple, so obvious, that it's almost embarrassing that no one had asked it quite that way before. Given the age of the universe, given the number of stars, given the time available for civilizations to develop and spread, where is everybody? Why haven't we heard from anyone? Why is the universe so silent? That question, the Fermi Paradox, is still unanswered today. And the possible answers are among the most profound and unsettling ideas in all of science. Let's set up the paradox properly, because it's more powerful than it might initially seem. The Milky Way galaxy is about 100,000 light-years across. It contains somewhere between 200 and 400 billion stars. It is about 6 billion years old. Even if only a tiny fraction of stars have habitable planets, and even if only a tiny fraction of those planets develop life, and even if only a tiny fraction of those life-bearing worlds develop intelligent civilizations, the numbers still suggest that there should be many, many civilizations in our galaxy, possibly millions. The mathematician Frank Drake formalized this reasoning in what became known as the Drake equation, a formula for estimating the number of communicating civilizations in the galaxy. Depending on the values you plug in, the answer ranges from one, just us, to millions. Now here's the key point. Even if a civilization only expands at a fraction of the speed of light, say 1%, it could colonize the entire Milky Way in about 10 million years. 10 million years sounds like a long time, but it's less than 1/10 of 1% of the age of the galaxy. Any civilization that got started even 100 million years before us, which is a blink of an eye in cosmic terms, should have had more than enough time to spread across the entire galaxy. And yet we see no evidence of anyone. No signals, no megastructures, no visitors, nothing. The sky is silent. The galaxy appears empty. And that silence is the paradox. The first category of solutions says that we are, in fact, alone, or nearly so. Maybe the origin of life is far rarer than we think. Maybe the transition from simple microbial life to complex multicellular life is extraordinarily unlikely. It took nearly 2 billion years on Earth and may have required a very specific set of circumstances. Maybe the evolution of intelligence is a 1 in a billion accident. Maybe the development of technological civilization requires such a specific combination of circumstances. The right kind of star, the right kind of planet, the right kind of moon to stabilize the planet's axis, the right kind of geological history, that it has only happened once, or a handful of times, in the entire galaxy. This is sometimes called the rare Earth hypothesis, and it has been argued in detail by paleontologist Peter Ward and astronomer Joe Kirschvink. The second category says that civilizations exist, but they don't last long. Maybe every technological civilization eventually destroys itself, through war, through environmental collapse, through the development of technologies it can't control. Maybe the window of time during which a civilization is both capable of interstellar communication and willing to engage in it is very short. If civilizations typically last only a few hundred or a few thousand years before collapsing, the chances of two of them existing at the same time and being close enough to communicate are very small. This possibility, sometimes called the Great Filter, is particularly sobering because it raises the question of whether the filter lies behind us or ahead of us. If it lies behind us, we are lucky survivors. If it lies ahead of us, we may be approaching our own destruction. The discovery of life on Mars, paradoxically, might be bad news, because it would suggest the Great Filter is not behind us in the origin of life, but somewhere ahead. The third category says that civilizations exist and are long-lived, but they are not communicating in ways we can detect. Maybe they have moved beyond radio waves, the technology we've been using to search, to communication methods we haven't invented yet. Maybe they are communicating with tight beam lasers, or quantum entanglement, or some technology we can't even conceive of. Maybe we are like a tribe in the Amazon jungle trying to detect the internet. The signals are all around us, but we don't have the tools to perceive them. This is sometimes called the zoo hypothesis in its more extreme form, the idea that advanced civilizations are aware of us but have chosen not to make contact, perhaps waiting for us to reach a certain level of development. The fourth category, and this is the one that keeps some scientists up at night, says that there is something out there and it is deliberately silent, or deliberately keeping us silent. The dark forest hypothesis, popularized by the Chinese science fiction author Liu Cixin, suggests that the universe is a dangerous place and that any civilization that reveals its location risks being destroyed by a more powerful one. In this scenario, the silence of the universe is not evidence of emptiness. It is evidence of fear. Every civilization that has survived has learned to hide, and the ones that didn't hide are gone. There is also the possibility that we are simply early. The universe is 13.8 billion years old, but it will continue to exist for trillions of years. The vast majority of stars that will ever exist have not yet formed. From this perspective, we may be among the first civilizations to arise, not because life is rare, but because we are early. The universe is young, and the great flowering of intelligence and civilization may lie billions of years in the future. In this scenario, the silence is not ominous. It is simply the quiet of a universe that hasn't fully woken up yet. Each of these solutions has different implications for how we should search for life and for what we should do if we find it. And none of them can be ruled out with current evidence. The Fermi Paradox remains one of the deepest open questions in science, and one of the most important. Because the answer, when we find it, will tell us something fundamental about the nature of intelligence, the fate of civilizations, and our own future. If you're finding this as thought-provoking as I do, hit subscribe. We're going to keep pulling on these threads, and the next episode is going to take us into the history of our search for signals from the cosmos. The Fermi Paradox is not just a scientific puzzle. It is a mirror that reflects our deepest assumptions about life, intelligence, and the nature of the universe. Every answer we propose says something about what we think is possible, what we think is likely, and what we fear. And the fact that we don't have an answer yet is not a failure. It is an invitation. An invitation to keep searching, keep thinking, and keep asking the question that Fermi asked over lunch more than 70 years ago. Where is everybody? The history of our search for alien signals is next, and some of what we've picked up is genuinely unexplained. Subscribe and keep watching. The story gets stranger.